Hello and welcome. Today we're going to be talking a little bit about trig, which is basically the branch of mathematics that allows us to connect the angles to the sides of a triangle. Up until this point we focused on one or the other, but they never really worked together. In order to pull that off, you need trigonometry. Trigonometry hinges on the main idea that you're working with a right triangle. If it's not a right triangle, all these rules do not work, so be mindful of that when setting up problems. You've got three basic ratios that are very useful: sine, cosine, and tangent. Sine is the ratio of the opposite side of the given angle divided by the hypotenuse. The crazy part is every right triangle in existence that has this same angle A will have the same ratio of sides, opposite over hypotenuse. Whether it's a little bitty triangle or a massive giant triangle, they all have the same ratio. Cosine is going to be your adjacent over the hypotenuse, and tangent is going to be your adjacent over the opposite. Notice that they switched the triangle on us. A moved from the bottom right to the bottom left. The location of A doesn't really matter. What matters is the side that's opposite the angle you're talking about, the side that's adjacent, and the hypotenuse. So long as you've got those three things straight, the direction of the triangle really does not matter. We got a handy dandy mnemonic for this, and it's SOHCAHTOA. SOHCAHTOA I like to call Pocahontas' sister, but it gives us all the setups in one spot. So my sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So let's try and put this stuff to use. Here we get a nice setup. When it's written this way, you can actually see the opposite over hypotenuse, and then we can do the problem. So sine of C. Sine of C is going to be my opposite of C, which is over here, divided by my hypotenuse of C. So it's just 21 over 29. And you are done the entire problem. The awesome part about this is that's just it. It's the ratio, 21 divided by 29, and you are finished. That is sine of C. C is an angle measure. Sine of C is going to be a fraction. So tangent of A, again, we're in this bottom left-hand corner. Tangent is going to be my opposite over the adjacent. Opposite's over here, so that's 12. And my adjacent is the one that's touching it, and that's 35. Done. Sine of A, be careful, they moved the triangle on us. A is down here, my opposite is up there, and my hypotenuse is always across from the 90. So my sine of A in this problem is going to be 32 over 40, which of course you're welcome to reduce. A little bit of a sneakier problem. Here I have my sine of A, so I've got my angle A marked, and my opposite is there, and my hypotenuse is there. So that's going to be 8/10. 4/5. However, in the same problem, they want me to talk about sine of B. Once I move to B, all of my letters change, or at least A and O change. This now becomes my opposite of B. It was the adjacent of A, but it's the opposite of B, whereas H is still H, it doesn't change. So my sine of B is going to become 6 over 10. So you really just have to be mindful of what angle you're working with and what the opposite, adjacent, and hypotenuse are for it. So here we get another one. My setup here, I want to try and pick a trig ratio that's going to involve my angle 72, the x, and the 20. From 72's perspective, x is going to be the opposite, and 20 is going to be the adjacent. So what I want to do is say that the tan of 72 is going to equal the opposite over the adjacent. Now this presents a problem because I don't know what tan of 72 is off the top of my head. It's something a little bit weird. This is where I run to my calculator. When I bring my calculator up, I've got a tan key. So I can press tan of 72. Before I press enter, I do want to be mindful of what mode my calculator is in. This is a very big issue in the park. It's a very big issue anytime you pretty much touch a calculator. It becomes more prominent even later in pre-calc. So I'm just going to go into mode and make sure that I'm in degrees. I am not. So it's a good thing I checked. So I'm just going to come over and I'm going to press enter to make sure I'm in degrees. Once your calculator is in a mode, it'll maintain that mode perpetually. So for our purposes in this class, we're going to be in degrees the entire time. So it's not something you need to worry about switching, but it's something you want to be aware of whenever you pick up a new calculator, you borrow from a friend or what have you. Be careful of what mode you're in. So I'm in degrees, and I'm just going to press enter. When I do that, I get a decimal answer. So tan of 72 is about 3.08. So in my work, I can just say 3.08 equals x over 20. Yes, you will have access to a calculator for the test. So if you encounter a problem like this one, you can work with it. If you don't have access to a calculator, the sneakiest move is just to leave it as tan 72. And you could just say 20 tan 72 equals x, and that's your final answer. If I have access to a calculator, I can get this decimal, 3.08, and then multiply it by 20, and that'll give me my answer. Note, it's the exact same thing. It's just a matter of whether or not you want a single decimal as an answer, or whether you want an uglier tan 72 times 20. Trig becomes very popular with word problems. We're going to do quite a few of them in this course, just to give you an idea as to how you might encounter them. You know you're dealing with a trig word problem whenever they talk about angles and sides. So we got this tree with an angle of 62 degrees. That's our angle statement. It's 15 feet away, so that's our side statement, and we want to know how tall the tree is. The hardest part is picking the right trig ratio to connect this together. I've got an adjacent and I've got an opposite, so I want to use tangent. And I would say tan of 62 is going to equal whatever my opposite is over whatever my adjacent is. I could grab a calculator and figure this out, but I'm just going to call it 15 tan 62 and call it a win. All right, so now we get to something a little bit more geometric. We got a triangle with sides ABC. You draw this triangle any way you want. Actually, yeah, we'll draw it any way we want. Now they say how long is BC. I can't draw any triangle I want because it does not work with non-right triangles. So I'm going to have to back up. It probably should tell me in the problem what kind of triangle it is. But I'm going to take the blame for that and just say I copied it down wrong. I'm going to put my A, my B, and my C. They tell me that little a is 4. It's standard convention when using one of these basic triangles that little a is across from angle A. So when they say little a is 4, they're talking about this guy right there. Sine of A is 4/5. It doesn't give me anything to mark in the triangle, so I'm just going to kind of put that over on the side. And they want to know, oops, I've already got BC. I'm going to call this AC in the given problem. So I can't just jump to an answer here because sine does not involve this 4 and this x. So I've got to be a little bit creative. But what I do know is that my sine is going to be the opposite over the hypotenuse. The opposite in this case was BC, and the hypotenuse is AB. So if BC is already 4, then I've got 4/5 equals 4 over, I don't know. Let's not call that x, let's call it y. In which case, I know that this is 5, because the ratio had to be 4 over 5, and it's already 4 over something. If it's 4 over 5 and 4 over something, the something is 5. Once I know that, I can then compute x just by Pythagorean theorem. You might even recognize that it's a Pythagorean triplet, and you can go straight for your answer. And we discovered that x is 3. So again, we got a triangle ABC, pretty similar setup. Might be nicer if they told us which one was the right angle. We know that A is 20, and we know that the tan of A is 5/12. What we're going to do is try and figure out the cosine of A. To find the cosine of A, I need to know the adjacent, and I need to know the hypotenuse. Now, I don't really know anything right now, but I know that the tan of A is 5/12. That tan of A should be the opposite over the adjacent. The opposite is already 20. So I can say 5/12 equals 20 over whatever my adjacent is, this AC length. I might recognize that this is times 4 as a scale factor, so that's going to be times 4, and I know that this is 48. Now that I know that's 48, I can do a little bit of Pythagorean theorem to be able to find the hypotenuse. Once I know the hypotenuse, I can take 48 over the hypotenuse. And then once you know what little c is, my cosine of A is just going to be 48 divided by whatever little c is. I'll leave that to you to finish, but the important part was that you recognize how they connect together. Okay, so now we've got a pre-drawn triangle. Again, notice the A and the A set up. But this one is distinctly not a right triangle. That's a big, troublesome fact for trigonometry, so I've got to be very mindful of that. So I know that c is 4. I know that little b is 10. And I know the sine of A is 8. I'm sorry, 0.8. This decimal kind of floated over. and I'm going to try and find the altitude to AC. Altitude is a game changer because that's a right angle, and now I've got a height that I can actually compute. I know the sine of A is the opposite over the hypotenuse, so this sine of A equals h over 4. Well, if 0.8 equals h over 4, I could either turn 0.8 into 8/10, or I could say 4 times 0.8 is just going to be 3.2. And now I have the length of the altitude. So like almost everything else we do in this class, if you can pick the right combination of how to progress from step 1 to step 2, then the problems aren't all that horrible. Life can get a lot better if you don't have access to a calculator, if you remember your special right triangles. These special right triangles that you talked about earlier on in geometry are really useful here. If you want to try and find something like sine of 45, that's going to be my opposite over the hypotenuse. These x's cross out. They don't really matter what they are. And you get root 2 over 2. All 45, 45, 90 triangles have this relationship. So this is one angle. I don't know what sine of 41 is off the top of my head, but I know sine of 45 because it's one of these perfect stops. You can do the same thing for any of these. Cosine is 60 degrees. For 60 degrees, that's going to be my adjacent over my hypotenuse. The x's cross out, which they will every time, and you've got an answer. So if it's one of those good angles, 30, a 60, a 45, you can always set up these ratios to be able to figure out your answer. All right, gang, I hope that trig makes a little bit of sense. If you have any questions on any of this, go ahead and post a comment on the Google Classroom, and we can have a conversation. Enjoy your break.